Hello students, my name is Shashank Shekhar and today we are going to start a new chapter, that is aldehyde, ketone and carboxylic acid. So basically these are all carbonyl compounds, so we will study one of them, each of them one by one. They are very important for your syllabus. Their chemistry is quite interesting as compared to all other functional group, like our talk about amines, or we talk about this haloalkanes or alcohol. Compared to all of these functional group, the chemistry of this aldehyde, ketone, carboxylic acid or any other carbonyl group is interesting. We'll look at it, why it is interesting, why it is different from each of those. Okay. Now coming back to the syllabus. So if you look at the syllabus here, so today we will be covering mainly the nomenclature, and also we'll give a quick look to the nature of carbonyl group. So basically we will see the bond structure of the CO bond, how it looks. Okay, so let us start our today's class. So these are the topics that will be covered today. First of all, we'll see the nomenclature of aldehyde and ketone. Afterwards, we'll see a table which will summarize all those nomenclature, including the common names. Okay, then I will try to make a presentation of how this N-substituted derivative groups looks like. So they are basically a derivative of your carbonyl group only the oxygen group is substituted by this nitrogen. So they are kind of derived from your carbonyl groups. At last we will see the structure of the carbonyl group, how does this C double bond O looks like. Okay, so let us start our today's class. So first of all, nomenclature. So the nomenclature rules, as you have studied earlier also, these are common for all of those say organic compound. First you have to find your longest chain, and then you have to number in such a way that your functional group comes first. Now what is new in this nomenclature about aldehyde and ketone, we will see that. So for ketone we have this suffix as ONE, and for aldehyde we have AL. Okay, so if you see the name of any simple alkane like your ethane, methane, propane, all of those ends with E. So what we will do, we will replace this E with AL or ONE depending upon the nature of the functional group. If it is an aldehyde, we will replace it with the AL, and if it is say ketone, we will replace it with the ONE, and the remaining name should be same. Means the base name, that suppose it is ethane, then the say base name is eth. Okay, so that would be same. We will write it as ethanol in case of aldehyde and ethanone in case of your ketone. Now in case of aldehyde, if you see, the longest carbon chain is numbered starting from the carbon of the aldehyde group, while in the case of ketone the numbering begins with the end nearer to the carbonyl group. Now if you look at what is meant here is that if you look at the structure of your aldehyde, you will find that okay, we will have this aldehyde only present on terminal. So what do I mean here? I mean that this aldehyde group can only be present at the terminal end. Okay, or on either on the extreme left or either on the extreme right. But this ketone can be present in between the functional group. Okay, anywhere in between the functional group other than the terminal end. So if you look here are the two examples of aldehyde. This is ethanol, this is another aldehyde which is having a long carbon chain. Forget about it, just look at the structure of this aldehyde. You will see that okay, this aldehyde is present at the extreme right terminal of this chain. Okay, so for numbering this compound, we will start numbering from this side in case of aldehyde, and for ketone we will start numbering from that side where the say unsaturated carbon that is attached to oxygen comes first. Clear? Now the substituents are prefixed in alphabetic order along with numeral. So what does it means? What does it mean? If you look at this example here, so it has basically 1 2 3 4 5 6 7 carbons are here, plus we have one carbon. So first of all, here also you have one carbon. So first of all, if you try to find the longest chain, so let us start numbering this all. Okay, I will not number it, means I am just trying to find the longest chain. 1 2 3 4 5 6. So this is 6 length. Okay, carbon chain of 6 length. This is of 1, 2, 3, 4. This is of 4 carbon chain length, and this is of 1, 2, 3, 4, 5, 6, 7. So you can see very clearly here that it is the longest one. This one is of 6, this is of 4, and this is the longest one. So what we will do, we will take this chain. Now what is the common mistake that students often do? So suppose you have to name this compound. Okay, so take the simpler example. Okay, here if you have to name this compound, then you will say that since it has only one carbon and it has one aldehyde group, then student make the mistake of naming it as methanol. They say that okay, we have one carbon and we have one functional group, but remember that do not get confused in this kind of simple things. You have to count that carbon also which is attached to this oxygen. Okay, so therefore you will count this as 1 and 2. So there are total of 2 carbons here rather than 1. For 2 carbons we have this base as ethe, and for aldehyde we have ethanol. Now let us try to number this thing. So I have told you that this one was the longest chain. Now from where we will start numbering it? So since functional group is present on the right end at the first carbon, if you try to number it from the left, right side, then we will try to number it from here rather than from this side where the functional group is present on the 4th carbon atom, and it is not having higher priority than aldehyde also. Therefore we will try to number it from this side, and this is the longest chain also. I have just counted the chain length. So we have 1, 2, 3, 4, 5, 6, and 7. Okay, at first position we have our aldehyde. Cool. Now at third position we have this methyl. At fourth position we have this bromo group. Now the question comes here that okay, your compound name would be methyl heptanol, because there are 7 carbons. So heptanol is for this 7 carbon plus aldehyde. Okay, this is clear. Now what about the substituents? We have 4 bromo and 3 methyl. Now some of you would think that since this 3 is coming first, that the methyl is coming first, so we'll place this methyl in the starting or as the prefix one. The prefix one. But it is not so. We place this functional group, or you can say derivatives, based on the alphabetic order. So if you see the name of these 2 substituents, these are bromo and methyl. Bromo starts with the letter B and methyl starts with the letter M. So we know it very well from the alphabetic order from ABCD that this B comes first. Then after that M comes. So therefore we will first of all keep this bromo first and then our methyl. Now where this bromo is present? It is present as 4th position. So 1, 2, 3, 4th position bromo is present, and 3 position methyl is present. So 4 bromo, 3 methyl. Now the thing here is to notice is that if you are writing a nomenclature, write it very carefully. Okay. So here you can see that 2 hyphens on 3. So if you have a functional group that is written in the middle of the our nomenclature, then you will put 2 dashes on both sides in case of any number is present there. Clear? So if it was suppose here it was one more methyl CH3 rather than this our bromo, then how would you name it? Do not take it as methyl, take it as ethyl, C2H5. Okay, take it as C2H5. Then how you would name it? So ethyl start with this E, so it would be same order, 4 bromo. Now put 2 hyphens before 3 and after 3, then write ethyl and then the rest of the name, that is heptanol. Now suppose we have one more methyl group here, or say we have one more group, like say we have this, take it as ethyl. This ethyl is present here, C2H5. Then how you would name it? So this would come at which position? If you count from here, it is 1, 2, 3 is methyl, 4 is bromo, 6 is your ethyl. So how you would name it? So its name is ethyl its name is bromo, its name is methyl. Now if you take the alphabetic order, then first of all the bromo will come. Okay, so let me write its name. We will have 4-bromo. Then we have the ethyl. Okay, so sorry for erasing it. Here will be our ethyl. Yeah. Now ethyl is at 6th position. 1, 2, 3, 4, 5, 6th position. So you will put 2 hyphens here. And why I'm writing ethyl first? Because after B your comes your E, that is ethyl. Then it comes your methyl M. So 4-bromo, 6-ethyl. Then we have 3-methyl. Then the rest of the name, that is heptaneol. Clear? So you will follow this canonical order. Just be careful in writing this name because children make mistake in these things. Okay, clear? So this is the nomenclature of normal aliphatic ring, which is substituted. Now we'll move to cyclic one. So cyclic one is same. The naming of the way of naming is same. Only we have to write a cyclo word here as prefix. So let us take the simple example of this thing. Now, how many carbons are here? 1, 2, 3, 4, 5 carbons. Okay. Now we can name number it in 2 ways. Let me write it clearly. What are the 2 ways? So suppose I start numbering it from here so that the functional group comes first. Then we have this 2. Then we have this 3, 4, 5. Okay. Now we can number it in other way also, other way around. That would be 1 here, 2 for this also, 3 here, 4 here, and 5 here. Okay. You could think of one more way of numbering it if you move from this side rather than this side, but that would be incorrect in all ways, because I have said that we have to say number this thing such that the functional group come first. If you number it here, of course 1 will be given to your carbonyl group, but then 3 will be given to your CH3 group. Sorry, 4 will be given to a CH3 group, and that would be not appropriate. So we'll start numbering it from this right side, 1, 2, 3, 4, that is clockwise. Okay. Now which of these will be preferred? Which of this numbering will be preferred? So you know it very well that this aldehyde has a greater priority than your methyl group. Okay. Your aldehyde group has a greater priority than your methyl group. Then you will start numbering it from this side, 1, 2, 3, 4, 5. In this way you will number it, giving the carbonyl group as the say priority. Okay. So it will look like this. Yeah. Clear? 1, 2, 3, then you have 4, then 5. So we are done with the numbering. Now how many carbons are there? 5 carbons. So pentane for that, pent for that. Which type of carbonyl group is present here? Ketone. So we'll name it as one, pentanone. Again, we are putting a cyclo against it, because there should be something that should differentiate a normal linear pentyl group with this cyclopentane group. Either in either case it will in other case it will create the confusion. So what we do, we are introducing a prefix, that is cyclo, in place or in front of this pentane group. So we have cyclopentanone. Now we have one more substituent here at 3rd position according to this numbering. Okay. So we will name that also 3-methyl cyclopentanone. So this is the complete nomenclature of this given compound. Now when the same thing written here, that when the aldehyde group is attached to a ring, this one, the same applies to a cyclic ketone where the carbonyl group is numbered 1. Okay, carbonyl group is numbered 1. Now let us take one more example here, so which is this ring along with a CHO group. Now its naming is not same as this normal our nomenclature. This is not same as our normal nomenclature, but it has one thing, that is this pronunciation, that is carbaldehyde. So when do we use this carbaldehyde? Okay, so see this thing. that when an aldehyde group is attached to a ring and which is not aromatic, here you can see that is not aromatic, then what do? We add a suffix carbaldehyde at the end of the full name of the say alkane. So how many carbons are there? You can see it very clearly. 1 2 3 4 5 6. So we have 6 carbons and they are present in a ring. So we'll write it as cyclohexane. What we will write? We will write it as cyclohexane. Again, I have told you in the starting that this CHO group will be written as carbaldehyde. Okay. So when aldehyde group is attached directly to a cyclic ring, then we write the whole name of the whole compound, and at last of that we will just try to number if there is another substituent. Otherwise we will directly write it as carbaldehyde. Clear? Okay. So here is the thing. Now one more thing about this cyclic group but aromatic one. So the name of the simpler aromatic carrying the aldehyde group is called as benzyl carbaldehyde. Benzene carbaldehyde. Okay. Or you can simply say it benzaldehyde also. This name is used often, benzaldehyde, rather than this benzene carbaldehyde. Okay. Now if it was a simpler group like this NO2 was not present here, then we would have called it benzaldehyde. And this benzaldehyde is the common name also and the IUPAC name also. So you should remember this thing. So you must have seen this common in this same different compound. Say we have this kind of CH2Cl. So we would say it chlorobenzene. Okay, we will call it not chlorobenzene. This benzyl chloride. Yeah. We'll name it as benzyl chloride. So similar to that, we have this benzyl aldehyde. Okay. Now what will happen if we have a substituent here? So you can see that we have 1 2 3 4. So at fourth position we will see that NO2 is present. You can count it from this side also, since it is present at the just opposite side of the symmetrical center. You will get the same numbering or same prioritization at 4 number. So we have a nitro group at 4 number. So 4 nitro benzene carbaldehyde or 4 nitro benzaldehyde. Okay. So this is the thing. So this was for say aromatic aldehyde. Now what will happen if we have more than one functional group or more than one carbonyl group present? Then you will use this suffix di, tri, etc. Okay, so di for 2, tri for 3, tetra for 4, penta for 5, and so on. Okay. Now how will number it? The greatest question is how you will number it. Now there are many possibilities. So first mistake the student make, that I have told you earlier, that number is in this way 1 2 3. They have not included this carbon at all, and this is completely wrong. Okay. So we start numbering from here, the one which contains functional group 1 2 3 4 5. Okay, so this is the one way of numbering it. The other way would be 1 2 3 4 5. Okay. Now from both of the sides we are getting this CHO group at third position. So this this way of the way of numbering is good, but we have not found this till the longest chain. So if you just number it, it will be 1 2 3 4. So it is basically smaller than our 5 chain length. Clear? Now we can number it from the either side. So I am numbering it from here 1 2 3 4 5. And how many lengths? So 5 length carbon. So we have pentane. Okay, we have this pentane. Clear? So this is the common name, that is propane 1 2 3 carbaldehyde. We can name it in the other way also, 1 2 3 tricarbaldehyde. So how it is named? It is named using this suffix, that is carbaldehyde. So if you use the word carbaldehyde, then this carbon is included along with this ring. But if you are not using it, then how it will be named? So we have said that we have 5 carbons. So pentane 1 3 5 tri al. Okay, so it would look like this: pentane 135 trial. But since we have used this suffix, that is carbaldehyde, which is already containing one carbon in its name, so we will name it in this way: 1 2 3. So at 1 2 3 we have carbaldehyde, so propane 1 2 3 carbaldehyde. So I would suggest that the previous one, that is including this carbon, is the more used up, commonly used nomenclature. Clear? So this was the nomenclature of IUPAC nomenclature of aldehyde and ketone. Now we'll see some examples and also some common names. So common names are important. You will see that most of the reaction we use terms like phthalic acid or citric acid, or say our oxalate. So all of those are derived from this common name. So you should be aware about the common name also, and it is very important to solve the questions, because in long questions you can see that they have used this common names rather than your IUPAC nomenclature. Okay, clear? Now we will move to our list of common name and IUPAC nomenclature. Okay, now, so this is the list of the common name and IUPAC name. So let us see each of these one by one. So I would focus on this common name because it is often used. So the first one is your simple methanol, and its common name is formaldehyde. Okay, so you must have heard this term formic acid, which is present in bees. So its structure looks like this: HCOOH. So if we have one carbon, then we use the name form, and since it is an aldehyde, we name it as formaldehyde. Again, it is the most important one. It is named as acetaldehyde. So this acet, that is ACET, it is derived from the vinegar name, that is acetic acid, which has CH3CO group. So if anything is containing CH3CO group, then we name this group as acet, ACET. Then we have the aldehyde, so acetaldehyde, and its common name is very obvious. It is ethanol. Then we have this thing. It is named as isobutyryl aldehyde. Isobutyryl aldehyde. So it looks like this. Okay. Yeah. And what is its name? So if you try to name it, yeah, let us do the nomenclature of it. Okay, so this is 1, this is 2, this is 3. 1, 2 and 3. So how we'll name it? So at second position we have methyl. So first we have numbered this thing. So it is done in wrong way, because the aldehyde group is present at third position. So we'll change this numbering: 1, 2, 3. So first we will put the base, that is prop for this. At 2 position we have the methyl. Yeah, then we have prop. At first position we have our aldehyde, so we do not have to worry about the numbering here. We will directly write as propanol. So 2-methyl propanol. 2-methyl propanol. Now see this thing. So how it is named? First of all, what did they do? We keep this thing as carbaldehyde. We have a carbaldehyde here. Okay. Now rather than numbering it, they have used this terminology, that is alpha, beta, gamma. Or since we have to prioritize this thing, then it will be alpha, beta, and this would be gamma. So at gamma position we have the methyl. Further we have a 6-member ring. Okay, of alkane. So we will write it as cyclohexane for this thing. Clear? And then for this CHO we have this carbaldehyde. Now what would be the IUPAC nomenclature of this? It was the structure. Okay. Now 1, 2, 3. At third position we have methyl. What is the base name? Oh, it will not include this thing. Yeah. So it will be cyclohexane. Then we have this carbaldehyde group. So cyclohexane, carbaldehyde. So 3-methyl cyclohexane, 3-methyl cyclohexane, carbaldehyde. Clear? Similarly, you can look at each of this. So I am just pointing out the important one here. So this one is very important, that is phthalic or phthalate. Okay, and I would say this formic and acetyl one is important. Then I would say this mesetyl oxide. Okay, so at least try to remember common name of these 3 to 4 compounds. That would be enough for you. Then try to name it also. Let us take an example of ketone. Okay, so it is written CH3 whole twice 2CH. Then we have COCH, and then we have CH3 whole twice. First, let us expand the structure. Okay, it is good. Then we have this CH3 on both sides. Yeah, so this is the structure. So first we will number it. So you can start numbering from either side. You will get the same priority of this aldehyde. 1 2 3 4 5. Okay, now what are the substituents? We have a methyl group of on 2 and 4 position, and at 3rd position we have a ketone. So what would be its name? So first of all, the methyl group. So 2,4 dimethyl. Okay, then what is the say this base name? 1 2 3 4 5. So pent. And at 3rd position we have pentanone, that is your ketone group. So 2,4 dimethyl pentanthreone. Okay, 2,4 dimethyl pentanthreone. Clear? Now remember all this thing, that is the hyphen on both sides and all. So with this I would move to the next slide. So these were some common names. So look at the common names also. They can be asked in the exam through reactions, and then you will get confused. Okay, so far we have studied the IUPAC nomenclature. We have followed the same rule except this carbaldehyde. So if there is a CHO group, we can just name it as carbaldehyde along with the name of the compound, along with the position of that carbaldehyde. Okay, clear? Now next we'll move to some of the derivative of the aldehyde. So when you will move to the reactions of aldehyde or ketone, you will see that derivatives are formed from the basic compound upon substitution. Okay, so we will see this thing, the name of this. So what happens if we substitute our aldehyde H with ammonia? Then it would result in the compound that is imine. So N is attached, double bonded to this carbon of that was previously your carbonyl group. Again, what happens if we replace this this H with an R? Then you will tell it as Skiff's imine or the Skiff's base. Sorry, substituted imine. This is called as imine. C double bond is called as imine. And if you replace one of the H with a R, then it will be called as substituted imine or Skiff's base. Clear? Now what will happen if it is a OH? If we replace our say this NOH, sorry, yeah, NH2, OH is written here. So if you replace your oxygen double bond O with NOH, they will get this thing. It's called oxime. Similarly with NH2, you will call it as hydrazine or hydrazone according to this. Clear? Again, we have this phenylhydrazine. So if you are replacing this say your H with a phenyl group, that is phenylhydrazine. Clear? Okay, so this is very important. Phenylhydrazine or phenylhydrazine is important. Now out of this, all of this one is the most important. It is asked often. So if we place a 2,4-dinitrophenyl group in place of this O, then it would look like this, and its name would be 2,4 dinitrophenylhydrazone. Okay. At last, we are replacing it with a what we're replacing? We're replacing it with NH on both sides. NHCO on the O side. So you will get this semi-carbazone, and its derivative was semi-carbazide. Clear? At last, now we'll move to structure of the carbonyl group. What is the structure of the carbonyl group? So this structure is very important to understand the mechanism of the reaction. So I will just give an introduction to it. In the next class, we will see that how this increase the reactivity. Okay, so let us start it. So far we were discussing this carbonyl group. We are just seeing the nomenclature. We have not seen our this bonding. So how does this bonding happen? First of all, if you look at the carbonyl group, this C double bond O, it is sp2 hybridized. So what does it mean? That out of the 3 valence p orbital, only 2 are included in the hybridization. So these 2 p orbitals and 1 s orbital of carbon, all of these orbitals, they combine and formed a set of hybridized orbital, which can do the sigma bonding. Okay, so which can form sigma bonding. Clear? So this is the structure: sp2 carbon, sp2 orbital, sp2 orbital, and sp2 orbital. Now what are we left with? So we have one more p orbital of carbon, of course, and we have one more vacant p orbital of this oxygen. Now what will happen? Not the vacant one, okay, sorry, not the vacant one, fulfilled orbital. So this is the vacant one in this case. Now what will happen? This will do side on side overlap. So you must have heard 2 types of overlap are there: head on head overlap, which is done by the hybridized orbital, that is sp2. This is the case of unhybridized orbital, and they will do the side on side overlap. So the 4th valence electron of carbon remains in p orbital and forms a pi bond with the oxygen by overlap with p orbital. In addition, the oxygen atom also has 2 non-bonding electron pair. So we are left with the 2 non-bonding electron pair here also. So because total it has 6 electrons, 2 of which are involved in bonding, 1 in pi bonding and 2nd in sigma bonding. So 4 electrons are left, or 2 pairs of lone pairs are left. Now, thus the carbonyl carbon atom and the 3 atoms attached to it lie in the same plane, and the pi electron cloud is above and below this plane. The angles are approximately 120 degree. So since they have overlapped, and we know that the sp2 hybridization, the ideal sp2 hybridization, the angle is 120 degree. So here it is the same. So this is the structure of the carbonyl group. So what happens? First of all, one s orbital and 2 p orbitals combine to form a sp2 hybridized orbital, and they do the sigma bonding with the oxygen and with the alkyl group, or the say with the any other alkyl group. It can be oxygen, or say it can be your not oxygen, it can be your say methyl, or it can be hydrogen. They do the head on head overlap to form the sigma bond. Now we are left with one p orbital of carbon and 1 p orbital of oxygen. So this 2 p orbitals, what do they do? They do the side on side overlap to make the sigma bond. So this is the to make the pi bond. So this is the pi bond. Now if you look at this pi bond, you can just look at this thing and see one more thing here, peculiar thing here, that okay, we have the electron density, but why it is in this shape? It is so because the oxygen is having higher electronegativity. So this electron cloud of p orbital is being polarized toward the oxygen atom, and we get this kind of lobe, anti-symmetrical lobe. Now what will happen? What will this do? So we'll see what will this do upon formation of this kind of C double bond O. Now upon formation of this bond, this kind of bonding, there is a kind of double bond here, C double bond O. Now this will further resonate, or you can say many other factors are there, which will just polarize this bond, and it will create a delta positive charge on this carbon. We will look at it in more detail, but now I'm just giving a glance of it, that the carbon group that is directly attached to the oxygen has increased nucleophilicity. What is the reason? We'll see in the next class. Okay, So with this, we have covered the IUPAC nomenclature of aldehyde and ketone. Also, we have seen some derivative of this. And I would suggest you to at least remember 3 to 4 common names that is asked often in the exam, or that are used often in the exam questions. Okay. At last, we have seen just a glance of this structure of carbonyl group. In the next class, we will see that how does this bond formation affect the nucleophilicity or increase the nucleophilicity of the carbon that is attached as a double bond to the oxygen. Clear? Okay. So we will see this, continue this thing in the next class. Thank you.